These are the typical kind of questions that you can expect in your finals. Okay, and you should understand the concepts uh, very carefully. So let's start with a basic quadratic equation. So the quadratic is x square plus bx plus c equal to 0. Okay. Now, the number of such equations that have real roots and coefficients b and c from the set 1, 2, 3, 4, 5. B and C can be equal as well. So how many such equations are possible? How would you solve this?
Sir, using the discriminant.
Very good. So they are talking about real roots. That means discriminant will be greater than 0. Right? And since they are saying that there is no condition given, and even B and C can be equal, so that means D can be greater than equal to 0 also, which means you can have double root. Right? Understood? So that means B square minus 4c should be greater than equal to 0. That means B square should be greater than equal to 4c. Okay. What is the second condition they have given? That B and C has to have values from 1, 2, 3, 4, 5. Right. So now, if C is 1, you have to start from C. If C is 1, what would be B? C is 1 means 4c is 4. So B square has to be greater than equal to 4. Right? So B can take
Sir, it
values
can
of,
be 2, 3, 4, and 5.
very good. Now if C is 2, then B square has to be greater than 8. Greater than equal to 8. So that means 3, 4, 5. C is 3. B square has to be greater than 12. That means B can be 4, 5. C is 4. B square has to be greater than equal to 16. So 4, 5. Right? C is 5. B square has to be greater than 25. So how many values? How many solutions? 4,
12.
3, 2, 2, 1. 12 solutions. Here? Understood? Please stop me if you have any doubts. Okay. This is the second type. X square plus x plus a equal to 0. And x square plus ax plus 1 equal to 0. These are two given equations. And the criteria is they cannot have a common real root for any value of a, have a common real root for one value of a, have a common root for two values of a, and have a common root for three values of a. I hope according to law. So how will you solve this? How do you solve this? How would you determine how many values of A will give common roots? What is the criteria of common roots? How do you resolve common roots? Okay, there's a formula for it, which is called the Cramer's formula. But if you, in case you don't know the formula, okay, you don't need to worry. You can start from the basic. Let the root or let the common root be alpha. So then what are my equations? Alpha square plus alpha plus A equal to 0. This is my first. And alpha square plus A alpha plus 1 equal to 0. This is my second equation. Right? Okay? Understood? So first, eliminate alpha square. Right? So if I eliminate alpha square, I can straight away equate the rest of it. That means alpha plus A equals A alpha plus 1. That means A minus 1 is A minus 1 into alpha. Right? So that means what do I get? Alpha by A minus 1 is 1 by A minus 1. Right? Clear? Understood? Everyone understood?
Yes, sir.
Now eliminate alpha. So if I have to eliminate alpha, I have to multiply the first equation with A. So I get A alpha square plus A alpha plus A square equal to 0, and alpha square plus A alpha plus 1 equal to 0. Just subtract the two. You get A minus 1 alpha square plus A square minus 1 equal to 0. So is A minus 1 into alpha square equals minus of A square minus 1. So A minus 1 alpha square is minus of A plus 1 into A minus 1. Right? So that means alpha square by A minus 1 is minus of A plus 1 by A minus 1. Right? Understood? Is it clear, guys? Or you can also write alpha square by minus of a plus 1 is 1. Right? Clear? Please stop me if you have doubts. What I did, I wanted to eliminate alpha, so I multiplied the first equation with a, right? So I got a alpha square plus a alpha plus a square equal to 0. And the second equation is already alpha square plus a alpha plus 1. So I subtracted the 2. So a minus 1 into alpha square plus a square minus 1 is 0, right? Okay. So from there, I can write a minus 1 alpha square is minus of a square minus 1, which is minus of a plus 1 times a minus 1. So from there, I can write alpha square by minus of a plus 1 is 1. Is it clear?
Yes, sir.
Okay. So that means from here, you can clearly say that a cannot be equal to 1. Because if a is 1, that becomes undefined. Right? So if a is not 1, then alpha is 1. Right? So that means one common root is alpha equal to 1. Right? Okay. But if alpha is 1, then you get 1 plus 1 plus a. 2 plus a, this is also 2 plus a. Right? If alpha is 1, then both gives you 2 plus a. For alpha equal to 1, both equations give a plus 2 equal to 0, which means a is minus 2. There. Understood? Is it clear? Yes or no?
Yes, sir.
So a equal to minus 2 is the only solution because a cannot be equal to 1. So a equal to minus is the only value of a for which you get a common root, which is 1. Okay. So they have a common root for exactly one value of a. Clear? Okay, clear?
Yes, sir.
Yes, sir.
Okay. This is the third type. Here, the equation ax square plus bx plus c equal to 0 has two roots, alpha and beta, such that alpha is less than -3 and beta is greater than 2. Okay? And a is not equal to 0. That means, obviously, if a is 0, then it becomes a linear equation, not a quadratic. That's why a is not equal to 0. Right? So one root is less than -3, the other root is greater than 2. Right? And you are given 4 options. Okay? Now tell me, how will you proceed on this one? What is the technique to solve this kind of questions? Anyone? Okay. A is not
Hello?
0. Yeah. Tell me.
Sir, can we write B as alpha plus beta and C as alpha into beta and then proceed?
So alpha into beta is actually C by A.
Oh, yeah, sorry. Yes, sir. C by A. And alpha plus beta would be B by
But,
A.
but how will that help? Look at the options. The options are given in terms of ABC, not in terms of alpha beta. If you are replacing ABC with alpha beta, then you are trying to convert the equation in terms of alpha beta. Right?
Yes, sir.
That will not help. You have to keep in mind what you are trying to do based on what are your options. Your options are all ABC. Right?
Yes, sir.
Okay.
Got it.
The first thing that you should notice here is A is not 0. What is the implication of this? That there can be two cases. Case 1, A is negative, or let me take A positive as the first case. And case 2, A negative. Okay. So if A is positive, then what happens? Then you get a parabola which faces upwards. And your roots are given as less than -3 and greater than 2. So suppose this is x equal to -3 and this is x equal to 2. Okay. So the parabola has to face upwards. One root has to be less than -3. Suppose the root is here. The other root has to be greater than 2. Suppose the root is here. I don't know where it is. But all I can say, the parabola will go like this. Make sense? Understood?
Yes, sir.
Okay. Why the parabola will go like this? Because one root is negative, less than -3. The other root is greater than +2.
Hello, sir.
Yes.
Sir, the option should be option. The correct answer is option B.
Okay. Can you explain why option B?
Sir, because it is given that alpha is less than -3 and beta is greater than 2. So for any, like if we take a greater than equal to 0 first, then we can say that for -1 and +1 both, the equation ax square plus bx plus c will be less than 0 if a greater than 0, and
Okay.
vice versa. If a less than 0, then ax square plus bx plus c will be greater than 0 for 1 and -1. Then
Okay.
that
Very
means
good.
that a minus b plus c, or and a plus b plus c both are less than 0 if we take a greater than 0. So a plus mod b plus c is less than 0 for a greater than 0. So a into a plus mod b plus c will be less than 0. Similarly, if a is less than 0, then a plus mod b plus c will be greater than 0. So again, a into the product will be less than 0, negative.
Excellent. Very good. You're right. So
Thank you, sir.
you have x equal to 1 here, x equal to -1 here. And these are the values of your y of 1 and y of -1. And both the values are negative. Right? So that means the quadratic value will be negative for x equal to +1 and -1. So if I put x equal to +1 and -1 in the quadratic, I get a plus b plus c and a minus b plus c. So a plus b plus c is negative and a minus b plus c is also negative from the diagram. That means I can say a plus mod b plus c is negative. Clear? Okay. And a is positive, which I have assumed here. That means positive into negative, a into a plus mod b plus c will be negative. One positive, one negative. Right? So that means this is not correct. This is correct. What about C and D? It can be multiple correct options also. That also you have to keep in mind. Competitive exam.
So C and D is wrong.
Okay. So C and D refers to -3, y of -3, which is also negative. Right? And you put -3 in this equation, you get 9a minus 3b plus c. This value is y of -3. So this is negative. Right? So this is given as positive, not correct. Right? And 4a plus 2b plus c, this refers to the value here, y of 2, which is negative again. So 4a plus 2b plus c is negative. So the product of these two has to be positive. So this is wrong. So only option B is correct as per a greater than 0. Now you have to also consider a less than 0. So for a less than 0, the whole concept remains the same. Only thing, the parabola will get inverted. So the parabola goes like this. Okay. So here y of -3 is positive, y of -1 is positive, y of 1 is positive, and y of 2 is positive. Right? So all four are positive values here. But a is negative. So the first one is y of +1 and y of -1. Both are positive values into a, which is negative. So the product has to be negative. So this is not correct. So this one is correct again. And this is y of -3, which is positive here, which is correct here, right? And the product of these two is positive again, because both are positive. So this is wrong. Okay. So that means the option B holds for both cases of A, less than 0, greater than 0. Option C holds for only A less than 0, but not for A greater than 0. So that is why option B is the correct option. Clear? Understood? Okay. Now we come to another type of equation, which is cubic equation. But though I'm showing this example with a cubic equation, it can be applicable to a quadratic also. Same concept. Now look at the question. 1 plus alpha by 1 minus alpha, 1 plus beta by 1 minus beta, 1 plus gamma by 1 minus gamma are the roots of the cubic equation fx equal to 0, where alpha, beta, gamma are the roots of the cubic equation given by this. Okay. Then the number of negative real roots of the equation fx equal to 0 is how much? How many? Now, how are you going to solve this question? If you don't know this type of question, please take a note of it, because this is a very, very important concept which comes in ISI and other exams very, very frequently. So what is the concept here? Look at the three roots given. 1 plus alpha by 1 minus alpha, 1 plus beta by 1 minus beta, and 1 plus gamma by 1 minus gamma. Just by looking at that, what can you say? Anyone?
Sir, can we use Descartes' rule of sign?
We will use Descartes' rule of sign, but we have to get the equation before that. They are not asking the number of roots of this equation. They're asking the number of roots of fx. So I have to find fx. You're right, but that's the second step. How will I find fx? So let us define a variable y, which is 1 plus x by 1 minus x. Correct? Now listen to this concept carefully. So for x equal to alpha, beta, gamma, y will be 1 plus alpha by 1 minus alpha, 1 plus beta by 1 minus beta, 1 plus gamma by 1 minus gamma. Agreed? Here? Everyone agrees with this? If I define y as 1 plus x by 1 minus x, then for x equal to alpha, beta, gamma, y will be those three which are given. Here? Yes? Right? So that means the roots that we are talking about, 1 plus alpha by 1 minus alpha, 1 plus beta by 1 minus beta, and 1 plus gamma by 1 minus gamma, will be the roots of the equation in Fy that we will get by using this transformation. This is called transformation of equation. Here. So I have to transform the given equation of x to an equation of y. This is what I have to do. Here. Understood? So from here, you can write y minus xy equals 1 plus x, right? And then you can write y minus 1 equals x into y plus 1, or x equals y minus 1 by y plus 1. Here. Understood? So now this is x in terms of y. Now you replace x here in terms of y to convert this to fy. So that means 3 into y minus 1 by y plus 1 cube minus 2 into y minus 1 by y plus 1 plus 5 equal to 0. Right? Here. Now you have to simplify this. Standard simplification. So 3 into y minus 1 whole cube. So you multiply with y plus 1 whole cube. So minus 2 into y minus 1 into y plus 1 square plus 5 y plus 1 cube equal to 0. So 3 into y cube minus 3y square plus 3y minus 1 minus 2 into y minus 1 into y square plus 2y plus 1 plus 5 into y cube plus 3y square plus 3y plus 1 equal to 0. So simplify this. So 3y cube minus 9y square plus 9y minus 3 minus 2 into y cube. Then 2y square minus y square is y square. Then y minus 2y is minus y and minus 1. Right? Here. Plus 5y cube plus 15y square plus 15y plus 5 equal to 0. So 3y cube minus 2y cube, which is y cube plus 5y cube, that is 6y cube. Then minus 9y square minus 2y square, that's minus 11 plus 15, which is plus 4y square. Then 9y plus 2y 11y plus 15y 26y, and then minus 3 plus 2, that's minus 1, plus 5 is plus 4 equal to 0. So this is your Fy, right? So now from here you can say 6x cubed plus 4x squared plus 26x plus 4 equal to 0. So you're simply converting Fy to Fx. Right? Now the question is, how many negative real roots this equation will have? Right? So here you have to apply not only Descartes' rule, but something else. What is that something else? Only Descartes' rule will not give you the answer. Why? Because this is your Fx. Right. Now, what is Descartes' rule telling you? The number of sign changes of Fx will give you the number of positive roots. The number of sign changes of f of minus x will give you the number of negative roots. So here there is no sign change for Fx. So number of positive roots is 0. Now we talk about negative roots. So we have to get f of negative x. So that is minus 6x cubed plus 4x squared minus 26x plus 4. This is your negative x. So that means 1 sign change, 2 sign change, 3 sign change. So number of negative roots can be 3 or 1. That is Descartes' rule. Right? It can be 3 or 1. And in the option, both options are given. 3 and 1 are both there. So what should be your choice? So that's why I said only Descartes' rule will not give you the answer. So to get the correct answer between 3 and 1, what you have to do is you have to look at Fx. Okay. Now Fx is a cubic. Okay. And a cubic can have 1 root or 3. Right. So f dash x is 18x squared plus 8x plus 26. Right? Clear? Okay. So you can reduce it by dividing by 2. So this is in effect 2 into 9x squared plus 4x plus 30. Right? So what is the discriminant of this? 16 minus 36 into 13, which is negative. Discriminant negative means this will never have any root. That means f dash x will never be 0. So f dash x is always positive. Here. So this means f dash x is always positive. Because discriminant is negative, the parabola will be above the x-axis. Here. So it will be always positive. So f dash x is positive means the graph is increasing, right? Always increasing. So that means to get, if I have to have 3 roots, if I have to have 3 roots, the graph must go up and come down and go up again. Only then you will have 3 roots. Otherwise, you can't have 3 roots. Here? Okay. Now, if this has to happen, then in this part of the graph, f dash x has to be negative, which cannot be the case as per this. That means it cannot come down. The graph is always going up, right? So therefore, the graph will be like this. So it will have only one root. Is it clear? Understood? Only Descartes' rule will not give you the answer here. It will give you either 1 or 3 roots. But whether it is 1 or 3 will be determined by the value of f dash x. In order for it to have 3 roots, it has to have a maxima and a minima. That means f dash x has to be 0 at some point. If f dash x is not 0, that means it will have only one root. This is a very, very important concept. Note it down if you don't know this concept, that for a cubic equation, if the first derivative is always positive, then that cubic equation will have only one root. Clear? Clear to everyone? Can we move to the next one?
Yes, sir.
Okay. So this question is a very, very critical question and important question, because there are two important concepts that I explained here. One is the transformation. Okay. From where we were able to transform the given equation to fy and subsequently to fx. Because unless you get fx, you cannot determine the roots. So first you got fy here, then you got fx from there. So from there, you applied Descartes' rule and you applied f dash x. Combining the two, you can say whether it will have one root or 3. Okay. Remember, the first derivative of a cubic equation will be a quadratic. And if that quadratic has 2 real roots, that means the original cubic will have 3 roots. It will go up and come down and go up again. But if the first derivative has no roots, like the case here, then the cubic will have 1 root. It will just go up. Here? Understood? Okay. So the combination of Descartes' rule and the first derivative is a very powerful concept to solve cubic equations. Okay. Next one. Consider the functions f1 x equals x and f2x equals 2 plus log x to the base e, where x is positive. Okay. Now the question is, where will the graphs intersect? So how do we solve this? Again, a very, very important question. So how do you solve this? Okay. To solve this, first define a function gx as f2x minus f1x, which is 2 plus ln x minus x. Okay. Now, the solution of these two equations will be the value of gx equal to 0. Okay. So gx equal to 0 will mean that that is the point of intersection of f1x and f2x. Here? Understood? Okay. So, how will I find this gx equal to 0? Okay. So, for this again, let me take g dash x. So, g dash x is 1 by x minus 1. Right? Now, if I take g dash x equal to 0, then I get x equal to 1. Right? That means at g dash x, there is a maxima, at x equal to 1, there is a maxima or a minima. So to determine whether it's a maxima or a minima, you do g double dash x, which is minus 1 by x squared. So at x equal to 1, g double dash of 1 will be minus 1, which is less than 0, which means this is a maximum. Here? Understood? So now, there has to be a maxima at x equal to 1. So let's say this is a maximum point. So that means the graph will be something like this. Here? This is x equal to 1. And the domain given is x greater than 0. That means between 0 and 1, there will be a point where gx will be 0. So that means this is one root of gx. which means this is one point of intersection of f1x and f2x. Clear? The second point of intersection will be greater than 1, but we don't know where it is. Here. Understood? Okay. So let us look at gx again. So 2 plus ln x minus x. So g of, let's say, 0.01 will be 2 plus ln of 0.01 minus 0.01. Right? Now, ln of 0.01, or let me take instead of 0.01, let me take g of e to the power 0.01. Okay. So this is a value which is very close to 0. So this is 2 plus ln of e to the power 0.01 minus 0.01. Right? Okay. So this value is what? Positive or negative? This value is 2. Correct? Sorry, this is minus x to the power 0.01. Right? So this value will be positive. Correct? Okay, so this is positive. Now let me take another value which is very close to 0. E to the power minus 10. This is very close to 0. This is 2 plus ln of e to the power minus 10 minus e to the power minus 10, which is 2 minus 10 minus, this is almost 0. Okay. E to the power minus 10. So this is negative. That means gx very close to 0 will be negative. So this will be a negative. G of 1 will be 2 plus ln 1 is 0 minus 1. So 2 plus 0 minus 1, which is positive. So that means g of 1 is positive. This is almost g of 0, which is negative. So there has to be a point where gx crosses the x-axis between these two values. So one value is here. Now, g of e. G of e is 2 plus ln e minus e. Which is 2 plus 1 minus 2.7, which is greater than 0. And g of e square. This is 2 plus ln e square minus e square, which is 2 plus 2 minus e square. E square is 2.7 square. So this is 4 minus, this would be roughly around 7. So this is negative. So that means g of e is positive, g of e square is negative. So therefore, g has to cross the x-axis between e and e square. So suppose this is g of e, and this is g of e square. So there has to be another root between x equal to e and x equal to e square. So therefore, there are two roots, one between 0 and 1, and the other one between e and e square. Okay, so I hope the concepts that I covered today are clear. Right? So in the next class, I'll cover more concepts on different types of equation solving and how to handle mix of equations. Okay, so that's all for today. Thank you. Bye.